I am Yin Tan, one of the team members for T01 for data science class named DS620 Machine Learning and Deep Learning. Our team consists of Vicky, Clement, Marie and Amy, and then Gayatri. Our presentation will be on the evaluation of machine learning algorithms' performance in predicting Alzheimer's disease. Our agenda for today will be the overview of the machine learning, deep learning problem and applications, data source, data validation, cleaning and preparation, model selection and training, then followed by model training performance analysis, model limitation, then followed by improvements and future work. We will have key references as the next slide, and finally Q&A. This slide, we will talk about the overview of the machine learning, deep learning problem and applications. We'll be focusing on Alzheimer's disease. Alzheimer's disease is one of the major causes of dementia, and detecting it early with the help of machine learning will provide timely medical intervention. This project will evaluate the performance of machine learning algorithms in predicting Alzheimer's disease. We will use 5 machine learning algorithms, which are k-nearest neighbors, logistic regression, support vector machine algorithm, decision tree, and random forests. And then we will compare the results to see which one performs better on the chosen dataset. The goal is to find the best algorithm with high accuracy score in detecting the disease. Machine learning allows us using mathematical and statistical models to achieve learning and adaptation without too many explicitly coded instructions. The algorithm learns gradually, continuously, and improves its performance over time. 2 of the imaging technologies used for Alzheimer's disease are magnetic resonance imaging and computerized tomography, which is known as CT. We focused on the MRI images and use machine learning algorithms to detect early Alzheimer's disease. Data source. We obtain our dataset from a catalog. There are 2 CSV files. One is called Oasis cross-sectional, and the other one is called Oasis longitudinal. So out of those 2 files, we chose the Oasis longitudinal file to perform our analysis on. For more details on why we chose the longitudinal dataset, please refer to our report. So the first step we did is to clean the data. After cleaning the data, we filter it to see visit where visit is number 1, because we use the longitudinal so we can see if there are any that went from not having Alzheimer's to having Alzheimer's disease. And then we can look at the information. Next, we will reset the index, and then we would look at the information. Finally, we check for missing values. Next step we did was replace the missing values with the median. And then we confirm the missing values has been replaced. Next, we replace the group column with converted. Those converted means the people not having Alzheimer's disease to actually diagnosed with having Alzheimer's disease. And then we replace the values in the male and female column with 0 and 1. And we do the same thing for the group. Since we'll be only looking at the group, so we drop the unnecessary columns such as MRI ID, visit, and MR delay and subject ID. For a complete list of all the columns in the dataset, please refer to our paper. And then we rename the column male and female to gender. And then we could take a look at the dataset again. And then we want to make sure all the columns are numeric. So we have to do a convert it to flow 64. And then we look at all the stats by using describe. And next that we do is using correlation plot to check the correlation between different columns. Model selection and training. So in this example, we'll be using logistic regression and support vector machine algorithms. For the other algorithms, please refer to our Jupyter notebooks. And so we first split the data set into X and Y. The Y would be the group, which is the main target variable that we are looking for. And then we split it into train and test, with the test size being 30%, and then we set the random C to 42. And then we scale X by using standard scalar, and then we fit the model. Then after transforming the data set, and we check out the shape, and then we will have go through the logistic regression model training, which can be seen as model underscore LR. And then for the support vector machine algorithm, we would do model underscore SVM. And then for the logistic regression, we are doing it for 20,000 iterations. And then we set the hyperparameter tuning for support vector machine. And then you want to find the best parameters, so we use grid search CV. And then we use the scoring as the accuracy. Then finally, after using the grid search CV, we will fit the model again, and then we find the best parameter. And then we take the best model from the grid search CV, and then we print out their accuracy. And then finally, we will fine tune a vector model training, support vector model training. And then we fit it to our new model. For a complete output of all we did, please refer to our Jupyter notebook. Then for model training performance analysis, we will use accuracy, cross-validation score, position, recall, and F1 score summary table. For the cross-validation, we use 10, and then we use to find a mean. And after doing it for both logistic regression and then for support vector machine, we put it in a data frame which used classifier, accuracy, precision, recall, F1 score, cross-validation. And as you can see that for logistic regression, we have a 87% accuracy, precision we have 93, recall is 74, and F1 score is 82, cross-validation is 88. While the support vector machine, we have accuracy of 89, precision is 1, recall is 74, F1 score is 85, while the cross-validation is 92. So this is only one of the models that we experimented on. Actually, two of the models that we experimented on. And then in our conclusion for this data set, the random forest classifier gives the best result of 0.933 accuracy. Moreover, the proposed algorithm can be able to detect Alzheimer's disease at an early age. In the future, the model could be improved by larger data sets and more machine learning models like ADA boost, voting, and etc. This will enhance performance and increase reliability. In this slide, we will talk about model limitation. Some limitations we have are result reproducibility due to randomness of data splitting, training and testing data, identification of relevant attributes due to limited availability of quality data. The current data set is small, 373 entries. It'd be better if there are thousands of entries, but unfortunately, the data set is pretty small. And more limitations are the choice of our machine learning algorithms, and the chosen algorithm might not work well identifying Alzheimer's disease. And also our team's current ability to fine-tune the hyperparameters, as we are all still learning about the field of machine learning. Improvements in future work. We would like to explore other data manipulation and cleaning methods. We just use what we learned in class, and there are other ones that we have not explored yet. And we would like to retrain the model using additional data as they become available. Also, we want to retrain the model using the relevant attributes. The attributes we chose may not be the best. Improvements in future work. And we want to select the most appropriate model suited for binary classification. And we would also want to select a different and larger data set, because as we mentioned before, the data set we have right here is pretty small. And having a larger data set would definitely benefit us. The models will have more data to train from. Key references. This slide only lists some of the references that we used. For a comprehensive list of all the references we used for our paper, please refer back to TP03. So here are only 3 of the ones that we used, which is the Mayo Foundation for Medical Education and Research, and then our textbook, Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. And then we also have Early Stage Alzheimer's Disease Detection using Machine Learning Models. This has come to the last slide of our presentation. Please, if you have any questions, feel free to email any of us or as a group. We'll be happy to answer any questions on why we chose the data set or why we chose the certain machine learning algorithms in our report. So just to reiterate, The algorithms we use were k-nearest neighbors, logistic regression, support vector machine algorithm, decision trees, and random forests. Thank you.